Think about the current conversations surrounding artificial intelligence. Most people are talking about how to build bigger brains for machines. They discuss training large language models and vision language models. They debate the ethics of alignment and the cost of compute. But there is a quieter conversation happening in the background that matters just as much for the real world. That is the conversation about orchestration. It is the difference between having a brilliant mind and knowing how to run that mind in a production environment without it crashing or bankrupting you. We are entering a phase where the technology has matured enough that capability is no longer the only bottleneck. In the period from early 2025 through 2026, the industry consensus is shifting toward agentic systems and efficiency. We are moving past the point where we just ask a model to answer a question. We are now asking how to manage a fleet of these models so they work together reliably. This brings us to 5 specific orchestration patterns that define production-grade artificial intelligence today. The first pattern is dynamic routing. Imagine you have a hospital with different specialists. You would not send a broken leg to a neurologist. Similarly, in artificial intelligence, you should not send a simple math problem to a massive, expensive reasoning model. Dynamic routing acts as a dispatcher. It analyzes the incoming request and sends it to the most appropriate model based on cost, speed, and accuracy requirements. If a user asks for a quick fact, the system routes it to a smaller, cheaper model. If the request is complex and requires deep planning, it routes to a larger engine. This is not just about saving money, it is about latency. By matching the tool to the task, you ensure the user gets an answer fast without burning through your budget on every single interaction. Now consider the second pattern, which is resilience through fallback chains. No system is perfect. Models hallucinate, APIs time out, services go down. In a production environment, you cannot afford to have your entire application freeze because one component failed. A fallback chain is designed to handle this gracefully. When the primary model fails to respond or returns an error, the system automatically switches to a secondary model. This might be a different provider or a smaller version of the same model. It is like a backup generator kicking in during a power outage. You do not want the lights to go out. You want the system to keep running, even if the quality of service drops slightly during the switch. This pattern ensures that your application remains available even when the underlying intelligence is struggling. The third pattern focuses on cost efficiency through semantic caching. This is a concept that many engineers overlook until their bills get too high. When a user asks a question, the system does not always need to call the model again. If a similar question was asked recently, the system can retrieve the previous answer. But it is not just a simple text match. It uses vector embeddings to understand the meaning behind the query. If the intent is the same, the system returns the stored result. This is like a librarian who remembers exactly what you asked for last week and hands you the book without you having to search the catalog again. This reduces the number of expensive API calls significantly. Over time, the savings are substantial, turning a potentially unsustainable operation into a viable business model. Moving deeper into the complexity of modern systems, we encounter the fourth pattern, which is agentic loops. This represents a shift from simple prompting to autonomous planning. In this setup, the model does not just generate text, it plans a sequence of actions. It might decide to search the web, run code, or query a database before it formulates a final answer. This is where the research from 2025 and 2026 becomes critical. We are seeing a move toward agentic autonomy where systems can handle multi-step tasks without human intervention. However, this requires careful orchestration. The system must know when to stop and when to continue. It must manage its own resources and time. If the loop runs too long, it can become a runaway process. The orchestration layer must monitor the agent's progress and enforce boundaries to prevent infinite loops or resource exhaustion. Finally, we must address the fifth pattern, which is human-in-the-loop oversight. As systems become more autonomous, the risk of error or ethical misalignment grows. This pattern introduces a safety valve. When the system encounters a situation it is not confident about, or when the stakes are high, it pauses and asks for human guidance. This is crucial for sensitive areas like healthcare or legal advice. It aligns with the ongoing debates about interpretability and safety. The machine does not make the final decision on its own. It proposes a course of action, and a human verifies it. This hybrid approach ensures that the speed of development does not outpace our ability to govern the technology. It bridges the gap between theoretical capability and practical safety. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.